Okay, here's problem 12 from Stallings Wireless. And this one says that it demonstrates that different linear feedback shift registers can be used to generate an M sequence, and that we could get different M sequences, okay? And in part A, we're using this LFSR, and we're seeding it with 10000, and this one has 5 registers in it, so the length of the sequence is 31, so it's kind of tedious to do. Basically, I did it here, and this was on graph paper, so it was easy for me to keep it straight. You can't see the graph paper here. But what we're doing is we're XORing bits 3 and 0 to get bit 4, and then we're shifting. Okay, so we have these diagonals. You can see these diagonals. Each bit shifts diagonally 1. Every bit is shifting according to the shift register, and then there's our output. Okay, so the only trick is to keep it straight and to XOR bits 3 and 0. So I'll do a couple of them for you. 0 and 0 yields a 0. 1 and 1. 1 and 0 yields a 1. 0 and 0 yields a 0, etc. And so that's how I get bit number 4 here. And the output then looks like this. And when I get to 31, as expected, I reproduce my seed state. That is the 10000 state. And that's exactly what I started with at step 0 here. 10000. And that's how you know you haven't made any mistakes, hopefully. And so here's the output sequence on the right. Okay. And if you do the statistics on this, you should get some pretty good statistics on it. And I just repeat the calculation for this different LFSR here. Okay. And I noticed here that sequentially you take bits 0 and 1 and XOR them, and then XOR that with bit 3, then XOR that with bit 4. And it turns out that when you're XORing bits, you don't have to worry about the order that you do them in. You don't need parentheses at all. Okay, so it's just XOR 0, 1, 3, and 4. Okay, so 0, 1, 3, and 4. You XOR all of those to get your next bit in register number 4. Again, we seed with 10000, and hopefully, and again we follow the same diagonal pattern for the shift registers, and then at step 31 we reproduce our seed state, that is the 10000. And what I've done here is I've compared the two M sequences. I took the M sequence of this one and the M sequence from part A here, and we notice that they really are different from one another. And so this illustrates that you may have two different M sequences. And that's it. It's just practice doing an LFSR, and it's kind of a big one because it's of length 5 registers here. So I hope that helps on 7-12.